Hello, welcome to my channel. This is Great Tutor, and what I do is solve technical drawing problems and also provide very important information that you can make use of for you to have better performance in your technical drawing examinations. You are watching my video for the first time. Thank you, and I want to ask that you subscribe to this channel, put on notification bell so that whenever I upload a new video, you notified, and help me share my videos with your friends who are technical drawing students. And it's very important that you practice this subject because it's a practical subject. When you practice it, you become a master at it. I came across this question somewhere and I want to provide solution to this question. Though I've saw something similar to this, but I just found that this question is just a little bit different from what we have done before, in the sense that we are asked to draw using a scale of 2:1. So I'm going to explain that, but let's look at what the question say with this diagram and know what we have to do with it. And as we have here that a hexagonal based pyramid is cut by a plane QQ as shown below. Okay, then here we have that draw using scale 2:1 the given elevation, the plan, the end elevation and direction of ROP, and shape true shape of the section true shape of the section. So that is what we are asked to do with this. We have 4 questions to ask, and I'm going to do everything in this same video. Okay, now as we have here, we're asked to use a scale of 2:1. The distance across corner as we have here is 25 multiplied by 2, that's 50, and the distance from here to here is 10 multiplied by 2, that is 20, and distance from the height of the pyramid is 30 multiplied by 2, that's 60, but the angle remains 30 degrees. You are not to multiply that by any by 2, so just leave it as 30 degree as given in the question. So let's see the first thing that we have to do. We're asked to draw the given elevation, and then we have to draw the plan. So the first thing to do is to draw we are going to draw a vertical center line. So we draw a vertical center line like this. Okay, so we draw a vertical center line. Okay, let me just extend it down a bit. All right, then we draw horizontal center line like this. All right, so then if we multiply that distance across corner given to us, which is 25 millimeters, by 2, that will give us 50 millimeters. So okay, so we are still going to take a measurement of 25 because that distance across corner is for the diameter of the circle that we are to use to construct that hexagon. So the radius will be 25. So we take a measurement of 25 millimeters and we draw a circle like this. So we draw a circle, and and with that circle that we have drawn, we are going to we are going to put the pinpoint of compass here. So we draw an arc up here and down here, and then we put it at this point here on the horizontal center line. We make an arc here, so we make an arc here. So we have 6 points on this. So we are going to join these 2 points together. So this point, we join them together like this. Okay, so we join these 2 points together, and then so we join these 2 points together like this. Then we join these 2 points together. So we join these 2 points together. So these points, we join them together. So here we have the hexagon. Then we are going to number these points. So this is point 1, this is point 2, so this is point 3, this is point 4, this is point 5, this is point 6. So those are the 6 corners of the hexagon. So we are going to join these 2 points together. So 4 and 1, so will be joined together. So 4 and 1 will be joined together like this, and then we also connect 3 and 6 together as we have connected 1 and 5 together. So we connect 3 and 6 together like this. Okay, so having done that, the next thing that we are going to do is to draw the elevation as we are instructed in the question. So we move our t-square up and we draw horizontal line like this. Then the next thing to do is to project this point. So this point, I will take it up, that is point 2, and point 1 and 3 are the same point on the circumference of the circle. So we project it. Point 4 and 6 are the same point on the circumference of the circle. So we draw this, and then point 5. So we also draw a vertical line to meet the horizontal line. Then we are going to take the measurement of the height of the pyramid. So as given in the question, it is 30 multiplied by 2, that is 60. So we take a measurement of 60 millimeters from this point on the vertical center line. So that is 60. So this is 60 millimeters. So I'm not going to connect. I'm going to connect this point together with the apex of the pyramid. Also, I will connect this point together with the apex of the pyramid. Also, this point will be connected together with the apex of the pyramid, and then we connect this point together with the apex of the pyramid. Okay, so now then, as we have in the question, so the point at which the cutting plane touched this side on the question given is 10 millimeters. So if you multiply by 2, that is 20. So that 20 millimeters, we are taking it on the vertical center line. You can't take it on this side, it will not be accurate. So you take it on the vertical center line. So that is what I'm going to do. So I will take a measurement of 20 millimeters here. This is 20. Then I will locate it. I'll just trace it to this slant side on the elevation. So this point, this is the point. So the next thing to do is to take my 30-degree set square like this and set it at this point. Then I will draw the cutting plane QQ as given in the question. So this is the cutting plane QQ. So this point is point Q, and this is also, so this is also point Q here. So the next thing to do is for us to make this a thick line. So make this a thick line. So this part has been cut off. So then you also make this a thick line. Next is you make this a thick line, and also we make this a thick line here. And then so we are going to make the base thick. Alright, so having done this, the next thing that we are going to do is to draw the complete plan. So this is the elevation now. As we are instructed, we have done that, we have drawn the elevation. So the next thing to do is to draw the plan, because by the time we remove this part that is cut off, we are going to have a rough surface. That roughness has to be shown in the plan, and that's what I'm going to do. So what you need to do now from this point here, so from this point, draw a vertical line. Okay, so if you look at this vertical line, this is 2.2 and this is 1,3. Okay, so this is 4,6 and this is 0.5 on the pyramid. So this is line 2 here. So this is line 2. This vertical line 2 meet this horizontal line 2 at this point. Okay, then we also do the same thing from point 1. So we draw a vertical line like this. So this line contains 1 and 3. So this is 0.3 here, and this is 0.1 here. Okay, then we draw for 4 and 6. So we draw a vertical line down here. So this is 0.4 here, and this is 0.6. So last one is 0.5. So if I draw a vertical line from here, so to meet this horizontal center line, so this is 0.5. So this point will be joined together. This point will be joined together. So we join this point together with this. So we join this point together with this. So we also join this point together with this. So we join this point together like this. And we also join this point together like this. Also, we join this point together. So the next thing that we are going to do here is to hatch the surface, as we have a roughness on this part here. So we use our 45-degree set square to make hatching lines here on this surface here. So and that is what I'm doing right now. So so these lines should be equally spaced. So drawn with thin continuous line. Okay. All right, so now, so that is the complete plan. All right, I've answered the first two questions. So I've drawn the given elevation and then I've drawn the plan. So next that I'm going to do is to draw the end elevation in direction of ROP. ROP is in this direction. So if I'm to put it here, so I'll just draw it like this. Okay, so ROP is in this direction as we have here. So this is ROP here. So now, so to draw that, so I'm going to draw a horizontal line. So from this point like this to this side. So then I will also draw a horizontal line from this point like this. So coming up here, I will draw a horizontal line from this point like this, and then from this base of the pyramid, I will draw a horizontal line to this side. Next thing I'm going to do is to take my 45 degree set square. So set at this point 2 on the front elevation, then I will draw a line in this direction. So now, next thing I'm going to do, so this center line, I'm going to produce it. So it goes up as we have the vertical center line here. So this vertical center line like this. So next thing I'm going to do is to project this point. So take it up to touch the horizontal line here, and then I will also take this up to touch the horizontal line here. Okay, so this line, contains, so it contains 3 and 4. So it contains 3 and 4. This line contains 2 and 5. So while this line contains 1 and 6 as we have here. So which means that if I go up here, I have 0.3 here, and then 0.3 and 4. This is 0.2 and 5, and this is 0.1 and 6 here. So the next thing I'm going to do is to take the measurement of the height of the pyramid, which is 60 millimeters, and I can also draw a horizontal line from the apex here, but I'll just take the measurement at 60 millimeters. So next I will join this point together with the apex like this, and then I will join this point together with the apex as we have here like this. Okay, so next thing I'm going to do is to draw a horizontal line from this point 5 here. So draw a horizontal line from this point 5. Okay, I will draw a horizontal line from this point. This point contains 4 and 6, and I will also draw a horizontal line from this point that contains 1 and 3 in the elevation, and I will draw a horizontal line from this point that contains 2. So the next thing to do now, having drawn these horizontal lines, so the next thing to do is to locate those points. So starting from here, so this is horizontal line 5 from the front elevation. So then vertical line 5, so it's we have 5 here, so this is 0.5 here. Okay, then we also have 2 on this line, so this is 0.2 here. So here we have 0.2, so this point is 0.2. Then here we have what we have 4 and 6. So this here we have what this is where we are going to have 6 at this point. We are going to have this 6 at this point, and here we have 4. So this is 0.4. So the next point is 0.1. So it is on this. We have this line contains what? This horizontal line contains 1 and 3. So this is 0.1, and this is 0.3 here. All right. So all I need to do is to join this point together to obtain the end elevation. So I will join this together. So this also, I'll join this together. So this will be joined together. Okay, so this will be joined together, and this will be joined together. All right, so the next thing to do, so I need to make this line a thick line from here to here. I will also make this line a thick line from here to here. So this line also, I will make it a thick line, and this line is also a thick line like this. Okay, then I'm going to arch the surface. So as we have here, so making arching lines on this surface like this. Okay, so this is the third question that we are answering. We have one more question left, which says that we should draw the true shape of the cut surface. So now, so we go for that. So this is the end elevation. This is how it will look. to go for the true shape of the cut surface. And it's very important. What we are going to do is to draw a line that is perpendicular to each of these points on this part here. So this cutting plane is drawn with 30-degree side of our set square, and to draw a line that is perpendicular to each of these points, I have to make use of 60-degree side of my set square, because 30 plus 60 will give us 90. So if I set my set square like this, I will draw a line. So this line is perpendicular to that point on the cut surface. So also I will draw from this point, and then I will also draw from this point. So all right, so the next thing I'm going to do is to draw a perpendicular line to these lines here. So this is it. All right, so now with what I've done here, so this point, if I follow this point, this is 0.2. So this point is 0.2. So this is 0.2, and this point here, if I follow this line, this is 0.5. This is 0.5. So I need to locate other point, and to do that, what I will just do is to take my compass. So this point contains this line, it contains 1 and 3. So I'll just put it in the middle, the midpoint. This midpoint that is on the horizontal center line, so which is this point, is in between 1 and 3. So I just put the pinpoint on my compass here, take this distance. I need to reduce this thing a bit. Okay, so I'll take this distance, so from here to here. Okay, so then I will follow this line. It contains 1 and 3, so I put at the midpoint here, and then I'll make an arc at this point, and also I'll make an arc at this point. So the next is, so for 4 and 6, so in the middle on the horizontal center line, I'll just extend it to 6, and I can also extend it to 4, anyone that I like. So this line contains 4 and 6. I will put it here, and I make an arc here. Also, I make an arc here. All right, so having done this, the next thing to do is to join this point together. This is point so this point is point 3. So this is point 3, while this point is point 1. So this is point 4, while this point is point 6 here. So I will join this together. So join 3 and 4 together. We join 2 and 3 together like this. So 1 and 2 together like this, and then 1 and 6 together. Okay, so 6 and 5 together. Then I will join 4 and 5 together. All right, so now, so we need to arch this surface. So with our 45-degree set square, so we produce arching lines here. So all right, so that is the true shape as we are instructed. It's as simple as I've done it here. All you need to do is to practice, and when you practice, you become a master at it. Thank you, and keep on practicing. God bless you.